Determine the equation of a parabola with focus at 2, 1 and directrix given by the equation 3x plus 2y plus 1 equals to 0. Let us begin. We'll try to understand the problem graphically first. So let's consider a straight line. We'll consider this vertical line to be having the equation 3x plus 2y plus 1 equals to 0. So as per the question, this is the directrix line. Now, we'll draw another line which is going to be perpendicular to the directrix line. And on this line, we're going to consider a point and call it F. Let's say this is the point having the coordinates 2, 1. So that means this is the focal point. Now, any line on which the focal point lies is going to be referred to as the axis of symmetry line. Now, we have these information, the focus as well as the equation of the directrix. Using these two information, we now need to find out the equation of the parabola. To find out the equation of the parabola, we begin by considering a point on this plane. And let's call this point as point P with the coordinates h, k. Now, P will be considered as the locus of the parabola. Now, the point P is chosen in such a way such that if we join point P and point F, and then drop a perpendicular from this point P on the directrix, let's say it meets a directrix at M, then the distance PM will be exactly equals to the length of PF. So this is the definition of a parabola. We're going to use this. So we now have the distance PF will be equals to PM. So we'll begin from here. Now we can easily obtain the length of PF. Here all we have to do is use the distance formula. So the distance formula states that we'll take a square root. Underneath the square root, we'll have to take the difference of the x coordinate. So we'll do h minus 2. That's the difference of the x coordinate. We square that value and then add it to the square of the difference of the y coordinate. So to find out the difference of the y coordinate, we'll take the y coordinate of P and y coordinate of F, take their difference to get k minus 1. This is going to be the length of PF. Now the next task will be to find out the length of PM. Now clearly PM is going to be the perpendicular distance of the point P from the straight line. So there is a formula for finding out this perpendicular distance. So let's go through that formula. So if we have a point P with the coordinates x1, y1, and then we have a straight line with the equation ax plus by plus c equals to 0, then PM is going to be the perpendicular distance of the point P from the straight line. And we can obtain this length by taking the absolute value. We'll take a ratio inside the absolute value. We'll begin by first considering the coefficient of x of the straight line, which is a. That gets multiplied to the x coordinate of point P. So we'll get ax1, then add it to b times y1, where b will be the coefficient of y of the straight line. And c is the constant term of the straight line. And this will be divided by the square root of. So here we'll take the sum of the squares of the coefficient of x and y of the straight line. So let's use this particular formula. So here we will begin by considering an absolute value. Inside the absolute value, we'll have to take a ratio. Then the numerator will consider the coefficient of x of the straight line or the directrix line. So that will be 3. 3 gets multiplied to the x coordinate of point P. So that's h. Then we add it to coefficient of y, which is 2. That gets multiplied to the y coordinate of point P. And then we have the constant term. So that's 1. This will be divided by the square root of. Now here we'll have to take the coefficient of x and y, square them and add them to each other. So we have 3 squared plus 2 squared. Right. Now let's compute this value. So what we'll do, we'll take the square root on both sides. That was going to give us h minus 2 whole squared added to k minus 1 whole squared equals to 3h plus 2k plus 1 whole squared. Now 3 squared, that's 9, and 2 squared, that's 4. So 9 plus 4 will be 13. So we have square root of 13 in the denominator, but after we square it, we're going to simply get 13. Now we need to simplify. We'll cross multiply 13 with the expression on the left hand side. So we get 13 multiplied to, now we have h minus 2 whole squared. So let's write it down. We have h minus 2 whole squared added to k minus 1 whole squared. This will be equals to 3h plus 2k plus 1 whole squared. Now that's a simple algebra which I'm leaving as an exercise for you to expand. I'll straight away write the final result. We'll be getting 4h squared added to 9k squared minus 12 times the product h and k. Then we have negative 58h minus 30k added to 64. This will be equals to 0. We're almost done. Now what we'll do, finally we're going to replace the value of h with x and the value of k with y, and that's going to give us the required equation of the parabola. We'll get 4x squared plus 9y squared minus 12xy minus 58x minus 30y plus 64 equals to 0. So this is going to be the equation of the parabola having a focus at 2, 1 and the directrix with the equation 3x plus 2y plus 1 equals to 0.